Hello, and thanks for joining me today as we discuss how road salt affects the environment we live in. As many of you have seen, salt is used in the winter to make the roads safer for those driving. In Pennsylvania, PennDOT has used 844,000 tons of salt in the past 5 years. That's about 168,800 tons per year, which is equivalent to 14,067 school buses per year. That's a lot. To explain how salt works on our roads, we need to take a closer look at the chemicals that make up salt. Salt starts out as a molecule made up of sodium, which is denoted as Na, and chloride, Cl. As the salt begins to dissolve, the negative chlorine ions attract the hydrogen of water, and the positive sodium ions attract the oxygen of water. Once the sodium and chloride ions have separated, salt has dissolved in water. Now that we understand how salt dissolves, we can look at how salt lowers the freezing point of water. When salt is added to water, it makes the concentration of pure water weaker. This way, the snow melts faster than it accumulates. Salt sounds great. It works on our roadways to make them safer for drivers, but what are the costs of using salt? Salt, which we just saw, is highly soluble. Due to this, salt increases the total dissolved solids in waterways. Increasing TDS can make respiration and photosynthesis difficult for aquatic life. Salinity is the amount of salt dissolved in waterways. Too much salt can contaminate the water. Also, as the salt makes its way to the water, it can degrade riparian buffer zones. If the riparian buffer zone is absent, then the salt cannot be filtered out before making its way to the waterway, which can contribute to contaminating that waterway. As this diagram, which demonstrates salinization, shows, salt from roads and parking lots are filtered by the green vegetation before entering a waterway. If too much salt enters the environment through any of these outlets, then the vegetation can be killed. With no vegetation, the salt will directly enter the waterway at very high levels. The EPA state that levels reaching 330 parts per million are dangerous to aquatic life after prolonged exposure. Environment Canada's research suggests that 5% of aquatic organisms are affected by chlorine concentrations of 210 milligrams per liter, and 10% when concentrations reach 240 milligrams per liter. Mayflies are an example of an indicator species. Indicator species indicate when water quality dips below healthy levels. These are the first organisms to be affected when the waterways are not at a healthy level. We learned about this common freshwater ecosystem issue through the Isaac Walton League Salt Watch program that everyone can get involved in. It's a form of citizen science, so visit their website if you're interested in monitoring one of your streams. Creek Connections has measured chlorine levels at Mill Run in Meadville, PA. Our results from 2019 show levels of 251 parts per million and 290 parts per million. Both these measures are above the EPA's acceptable levels of 230 parts per million. As we can see, there are costs to using salt. There are some replacements to salt, however, which include organic alternatives, such as beet juice and pickle brine, other chemical methods, such as calcium chloride, and technology, such as porous pavement. The most important aspect of salting is to salt responsibly. Some alternatives you could try at home are kitty litter or birdseed. Larger operations, such as PennDOT, could try combining salt with safer methods and mix an alternative with salt. There are two activities that follow this PowerPoint. The first is using salt added to ice to see how it lowers the freezing point of water. The second is placing a carrot into salt water to see the connection between salt use and vegetation. Thank you for joining me today. I hope you enjoy the rest of our symposium.